sine function. This is called 6.5 law of sines. But I'm not going to write the whole thing out. I'm just going to tell you what it is. It is ratios from angles to the opposite side of the triangle. That's what the law of sines is. So I'm just going to draw the picture. This is notice this is not a right triangle. I didn't give any 90-degree symbols in here. And this is the whole point. We are dealing with being able to find every piece of this triangle, provided we have certain pieces of information. So the law of sines states this. If this is A, we'll call this little a. A, segment BC, is not attached at vertex A, right? So I know that that is the opposite side of angle A. Would you agree? And it's very easy to see because this is a triangle that shows that. I could put a really small triangle on here that's bent over and it's hard to see that. But my point is this segment does not touch this vertex. That's how you know what the opposite side is. We'll call this little b, and AC is not attached at all to angle B. So that is the opposite side of angle B. And C, we'll call this little c. That is opposite of angle C. BA does not touch that vertex at all. So that's how you know what an opposite side is. Okay? Same thing with SOHCAHTOA, opposite over adjacent, opposite over hypotenuse. It's the exact same type of thing, except SOHCAHTOA deals with 90-degree right triangles. Okay? Law of sines says this, that the angle is to its opposite side as the other angles are to their opposite side. Now for proportion you only need two ratios, two fractions. So you have to pick and choose which of the three you use. So if you understood this, you should be able to do half of the problems today. The other half is just one little extra step from there. Okay? So let's look at two examples. This example, I'm going to do a different one in this class. Example 6. Here's your triangle. I don't want it to be a 90 degrees, so I'll try to draw it a little bit differently. C, B. This angle is 67. This is 56.3. And this is 80.2. And I want to know theta. I'm going to teach you the harder problem of your assignment first. Not that there aren't more difficult ones, but for the teaching part, this is the harder one of the two. So we'll just do two of the problems like this. Now, we're going to use law of sines. This is not a 90-degree triangle, so we can't use the Pythagorean theorem. I'm not asking for the area, so you're not going to use 1/2 AB sine of theta. Right? You're going to use law of sines. So you look at this and you say, what do I know? I know that angle and that opposite side. That's the law of sines. So all today you're going to do the sine of whatever thing we have here. Sine of 67 degrees is to 80.2. That's the first ratio. That's the easy one. You have that information. What is it we're looking for? Whatever it is you're looking for, you need to make sure you have that in your proportion. It's just like in your proportions, you always had x and you had to cross multiply to find x. This is the same thing. You have a piece of a proportion missing. Which part is missing? What are we looking for? The sine of b. We want theta. So the sine of b, in this case I'll say sine of theta, is to what? 56.3. Now you have your handy-dandy calculators out. You're in degree mode because you're dealing in degrees. What is the sine of 67 degrees on your calculator? Oh, you don't have that. I'm sorry. What? Hopefully this works. Nice. Just make sure it's in degree mode. Sine of 67 degrees.
0.92.
Go up 4 decimal places.
0.05.
Really?
Yeah.
Okay. Just looks different. How do I solve this equation? Cross multiply. Okay, so you're going to take point. Did you get this? 0.9205 is not the right move. Everybody cross multiply. Oh. Sine 67.
Yeah.
What did you put in? What did you put in? Show me. Do it again. Show me.
4.
67.
Probably touching those.
Okay. All right, now you do cross multiplication. Tell me what that number times 56.3 is.
8.
56.3 times this. What do you get? 4. Okay, good enough. So sine of theta times 80.2. Now how do I get sine of theta by itself? It's just algebra at this point. What do? Divided by 80.2. So now I take that number, divide by 80.2, and that tells me the sine of theta. What is the sine of theta? Just divide by that. Everybody? Follow along and do it so that you're getting the same things. Now it does all depend on if you rounded and then used the rounded form, or you left it in your calculator and used the long number. Your numbers are going to come out just a little bit different depending on if you rounded. Okay? So if you're within a degree of your answer in your problem in your book, that's okay. Alright? I always try not to round when I'm doing the problems, but whatever. You're not done though. So you'd be done on a typical problem, except now I want you to know the degree. To find the degree, this is what you learned yesterday. Don't I take the inverse of this and just switch these two numbers? So the inverse, or the arc sine of 0.6462 on your calculator is going to be my degree. So that's what you do at this point. Because you're gonna half your problem is going to have this in it. So you do the arc sine of 0.6462, and what do you get?
40.3.
40.3 degrees. This was the extra part I was talking about. That wasn't that difficult, was it?
No.
That's it.
I'm actually.
So what are you doing today? You got to set up your proportion with the law of sines, and then cross multiply. Make sure you're in degree mode. And if you're looking for the degree, half of your assignment, you're not looking for a degree, you're looking for a side. And if you're just looking for the side, you're not going to have to do the inverse because you're not looking for degrees. So you'll be done at this point. All right? And then the other half, you're going to have to do the inverses. Any questions? All right, your assignment. Page 473. Four to 28 evens. These are evens.